In this section, we're going to talk about network protocols. Let's start with network message delivery options. To deliver a message in a network, we have three options: unicast, broadcast, and multicast. Unicast is the term used to describe communication where a piece of information is sent from one point to another point. In this case, there is just one sender and one receiver. Broadcast is the term used to describe communication where a piece of information is sent from one point to all other points. In this case, there is just one sender, but the information is sent to all connected receivers. Multicast is the term used to describe communication where a piece of information is sent from one point to a set of other points. In this case, there is sender and the information is distributed to a set of receivers. Let's explain these network message delivery options with an example. For example, let's say that here is an apartment and let's say your friend Sally lives in here. You want to visit Sally, you come to entry of the apartment, and if you just ring the doorbell of Sally, this is you, an ugly guy. If you just ring the doorbell of Sally, that is unicast. And let's say that in this apartment we have also Hillary and John is living. If you ring the doorbell of Sally and Hillary, this is multicast. If you ring the doorbell of Sally, Hillary, and John also, this is broadcast. In the broadcast, you disturb Hillary and John, as you can see, because you will go to Sally's home. That's the difference. That's the key difference. Let's go ahead with network protocols overview. A protocol is a set of rules that governs the communications between computers on a network, as you see on the screen. These rules include guidelines that regulate the method of access, types of cabling, and speed of size data transfer. And let's go ahead with the standards organization. A standards organization, sometimes referred to as a standards body, is an organization with authority to endorse official standards for given applications. The most important standards organizations are ISO, ITU, ANSI, IEEE, EIA, OMA, and W3C. Let's go ahead with protocol suites. A protocol suite is a set of related protocols that work together in the context of a larger protocol stack. For example, the TCP/IP protocol suite, which is the basis of the Internet, is a collection of related protocols that are used in various combinations to serve specific applications. TCP/IP protocol suite is the conceptual model and set of communications protocols used on the Internet and similar computer networks. The Internet Protocol Suite provides end-to-end data communication specifying how data should be packetized, addressed, transmitted, routed, and received. This functionality is organized into 4 abstraction layers which classify all related protocols according to the scope of networking involved. From the lowest to highest, the layers are the network access layer, internet layer providing internetworking between independent networks, transport layer handling host-to-host communications, and the application layer which provides process-to-process data exchange for the applications. And let's go ahead with the OSI reference model. OSI module is a reference module created by ISO for how applications can communicate over a network. It conceptually divides computer network architecture into 7 layers in a logical progression. Before OSI, guys, it was almost impossible to create a communication between different vendor devices. For example, an IBM device could just operate with another IBM device. The purpose of OSI reference module is to guide vendors and developers so the digital communication products and software programs they create will interoperate and to facilitate clear comparisons among communication tools. Most vendors involved in telecommunications make an attempt to describe their products and services in relation to the OSI module. Today, many vendors, for example Alcatel, Huawei, Cisco, IBM, and etc., can operate each other by the help of the OSI module. Here, as you can see, OSI consists of 7 layers, and they are physical, data link, network, transport, session, presentation, and the application. We are going to talk about much deeper about each layer on our later lessons. And let's compare this OSI and the TCP/IP modules. There are some key differences between OSI and TCP/IP modules. TCP/IP has 4 layers, as you can see in here: application, transport, internet, and the network access. But OSI module has 7 layers. TCP/IP makes no assumptions about what happens above the level of a network session, part of OSI layer 5, while OSI defines several more layers of standardized functions. TCP/IP makes no prescriptions as to the link layers below IP, while OSI specifies 2 layers. If an application needs functions not found in TCP/IP, the application has to supply them. In the OSI module, it is assumed an application will never implement any functionality belonging in any defined layer, and because interfaces between layers abstract many details, it may not be able to anyway. And let's go ahead with the moving data in our network. When data moves from upper layer to lower level of OSI, each layer includes a bundle of relevant information called header along with the actual data. For example, let's say that PCA wants to communicate with PCB, and this guy is the sender and this guy is the receiver. While PCA is sending a packet to the PCB, each OSI layer will add their headers to the data. For example, presentation layer will add its own header. Transportation layer will add its own header. Network layer will add its own header, and etc. The data package containing the header and the data from the upper layer then becomes the data that is repackaged at the next lower level with lower layer's header. Header is the supplemental data placed at the beginning of a block of data when it is transmitted. This supplemental data is used at the receiving side to extract the data from the encapsulated data packet. This packaging of data at each layer is known as the data encapsulation. Encapsulation is being received on this way. The reverse process of encapsulation is de-encapsulation, and de-encapsulation occurs when data is received on the destination computer. As the data moves up from the lower layer to the upper layer of OSI, each layer unpacks the corresponding header and uses the information contained in the header to deliver the packet to the exact network application waiting for the data. In here, what is gonna be is that, for example, data is encapsulated in here with the headers, and in here, this time, each layer will unpack the data and will de-encapsulate it completely. Let's go ahead with the protocol data units. A protocol data unit is information delivered as a unit among peer entities of networks containing control information, address information, or data. In layered systems, PDU represents a unit of data specified in the protocol of a given layer, which consists of protocol control information and user data. PDU is significant term related to the initial 4 layers of the OSI module. In layer 1 and in here, PDU is a bit. As you can see, these are the bits. In layer 2, our PDU is frame. In layer 3, our PDU is a datagram. And in layer 4, our PDU is segment. Let's go ahead with the MAC and IP address terms. A medium access control MAC address of a device is a 48-bit unique identifier assigned to network interfaces for communications at the data link layer of a network segment. MAC addresses are used as a network address for most network technologies, including Ethernet and Wi-Fi. An Internet Protocol IP address is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. Having an IP address allows a device to communicate with other devices over an IP-based network like the Internet. As you can see in here, MAC addresses work on OSI layer 2, but IP addresses operate at OSI layer 3. MAC addresses are 48 bits length. IP addresses may be 32 or 128 bits. If it's IPv4, it's 32. If it's IPv6, it's 128. IP addresses are shown in decimal or hexadecimal format, but MAC addresses are just shown in hexadecimal format. Here is an example of a MAC address: 00 double column 0A double column 95 and something like that, as you can see. And here is an example of the IPv4 address. We are going to talk about much deeper about MAC addresses and IP addresses also in our later sessions. And let's go ahead with the ARP request. Address Resolution Protocol, ARP, is a telecommunication protocol used for resolution of IP addresses into MAC addresses. For example, if host A wants to communicate with the 10.0.0.2 PC by using the same switch, host A needs the MAC address of the device, and for this purpose, host A sends a ARP request. Here is the details of the ARP request. Host A says that, hey, I want the MAC address of 10.0.0.2. Who is 10.0.0.2? Tell me your MAC address. This guy takes the request and replies back with an ARP reply, and this ARP reply packet includes the MAC address of this PC. Here is the information included in the ARP reply. Hey, here is my MAC address. I am 10.0.0.2, that's me, and here is my MAC address. If you want to communicate with me, you can use my MAC address. Alright, let's talk about how we can communicate in the same network. Communication in the same network is made over MAC addresses between devices, and packet is not sent to default gateway, which is the interface of a router. We are gonna see this guy and how this operates deeply again in later sessions. But please keep in mind that if you want to communicate by using the same switch, for example, if PC1 wants to communicate with the FTP server in here, the communication is made over just MAC address. But if you want to communicate with the remote network, packet is sent to default gateway of the client if a communication is wanted. Alright, what we're gonna make in here, if PC1 wants to communicate the web server on the remote side, the packet will be sent to the default gateway, which is this interface of this router device. Alright guys, I know that we don't still know what a router is, we don't still know what a default gateway is also, but just please keep in mind what is going on. I'm gonna explain all of these guys to you step by step on the other sessions. Alright, and if PC2 also wants to communicate with web server, this guy should also send the packet to the default gateway. Alright, that's the thing that we need to really focus on. If you want to communicate with a remote network, you are sending the packet to the default gateway. If you want to communicate with the internal network, that's no problem. By using a single switch, your communication is just made over the MAC addresses.